Awesome. Super excited to be here. Thank you for making time. Very, very excited to kick off the conference and kick off the summit and talk a little bit about the way we do machine learning at the companies that I've worked at. I'm going to primarily talk about Shipt. A little bit about me. I am an engineering turned product manager. I was an engineering manager before I switched over to the dark side, like I said. As Aarti said, I used to build machine learning models as an engineer, in my past life. I got the fortune of working at companies like Amazon, Yahoo, Microsoft. I worked for search algorithms. I worked for marketplaces, Amazon being the OG marketplace, if you will. And then at some point, I actually switched over to product at a game called Words with Friends. Has anybody heard of this game? I see a few heads nodding in the audience. So used to be very, very popular. The game is still around, but it's mostly you're playing Scrabble with other people. So imagine playing it on your phone with other people, and it's a turn-based game. That's where I started my product journey. Moved over to Lyft, which is a big ride-sharing marketplace for those of you who are not from the US. It's the number 2 competitor to Uber in the US. And now I'm at a company called Shipt, which is essentially it's a competitor to Instacart, DoorDash, Uber Eats. It was the largest acquisition of Target 4 or 5 years ago in the history of Target. So, we are pretty big, but we are privately held. So, it doesn't make the media circles as much as the public companies. So I'm really going to talk about 3 things today. And my talk is really divided into, I'll talk about how we do machine learning at Shipt. So, I'm going to talk about what are some of the models that we use, what are some of the problems, use cases that we are solving for. I'm going to talk about, take one of those examples and talk about how we launch machine learning models. I'm going to go through some experiences that we have faced in one of our launches, which we are actually about to finish tomorrow. And it's been a long journey. So I'll give you some overview of how that happened. And then finally, we are just going to recap with key takeaways, and I'll leave some time for questions as well. So just to set the stage, Shipt is a 3-sided marketplace. And the 3 sides really are, so it all starts with demand. It all starts with users like you and I, for example, placing an order into the marketplace. Think of yourself as, for example, placing a delivery order at Uber Eats or DoorDash. It's the same idea. We actually go beyond that. We support a use case for shopping and delivering something. So you can put a grocery order where the first side is the customer or the user, which places the order into the marketplace. The second side is the store or the retailer where that order is being shopped from, right? So that's side number 2. And the third side, which is where I am at the company, is really the gig side of the company or the shoppers who will go and shop the order or they may pick up the order. So shopping from, for example, a Whole Foods, or picking up, for example, from a Target when they're not, they may or may not be shopping, just picking up an order, or from CVS, an RX subscription, for example, a prescription subscription. So those are the two primary use cases, shopping as well as delivering. And for that we use a gig workforce. So similar to Uber Eats, similar to DoorDash, Instacart, the company is built on a flexible, elastic workforce. And I am on that side of the company. So most of the machine learning that we're going to talk about today, models that we're going to talk about, actually impact the gig side of the company. And for any of you who have worked for any gig company, you will probably identify with the fact that side of the company, the supply side of the company, is actually very challenging to maintain for many, many reasons. We'll talk about some of them as we go through it. So we use many, many models at Shipt. I'm going to talk about the models that my team owns and we use. There are many more. And even on this slide, there are actually a lot more models under the hood. But I'll give you a few simple examples just to sort of set the stage of what we're going to talk about. So imagine an order, right? Imagine that you are a marketplace, a delivery marketplace. An order comes into the system. The first thing that we try to do, any other company tries to do, is they try to basically see if they can actually pool the orders together. So a common example, a good example is Uber Pool. for those of you who know what Uber Pool is, a car is going from a source to a destination, point A to point B, and it's probably going to go, there's probably going to be extra capacity in that car. You're going along that route anyway. Why don't we actually try and, top up the capacity by adding more, more passengers into that car? It's the same idea. We have something called bundling, where a shopper or a driver is going to go from a store to deliver an order to a customer. So why don't we give them multiple orders? We call that bundling, which is the first one that you see on the slide. So number one is a model that actually bundles these orders together, and and that's what you see on that slide. So just to take a step back from here, what you are seeing here is actually the shopper app, which is as a shopper, there are two different tabs. As I said, there are two sites. There are actually three sites, so there are three. Everybody has sort of their own interface into the company. But just to take a step back, this is the shopper app where if you signed up to be a Shipt shopper, you would essentially download a Shipt app, and then you could, when you go to the app, depending on where you live, what you set as your location, for example, you will get orders in that location, and it's up to you whether you want to take that order, accept that order or not. So we call it offering. There's a matching system. We call that offering. So it's up to you whether or not you want to take that order. And this is sort of a stream of orders that you will see in the app if you were a shopper, if you were using that app. So coming back, first we try to see if we can bundle the orders together for the same shopper to be able to do more work, especially if the orders need to be delivered around the same time in the same vicinity, in the same area. It's a win-win-win for us as well as for the shoppers, because the shoppers are essentially working more, and if they work more, they get paid more. It's the philosophy behind paying at Shipt for the shoppers is obviously the more you work, the more you will get paid, right? It's a contract. They are all independent contractors essentially. So that's sort of the model. It's not a salaried fixed hourly employee model. It's the way as much as you work, you actually get paid for it. So it's a win for them. It's a win for us because by merging these things, we actually get economies of scale because our unit economics improves. Because we are combining parts of the journey, especially the driving part of the journey, together to one shopper, for example. So things like that. So first one is bundling. That's one machine learning model. The second one that you see is what I touched upon is for a job, we try to estimate how long would it take for you to finish this job. I'll talk a little bit more deeply about that model as we look into one of the models that we launched, the one that I was talking about. So we'll get into that. But there is a model that estimates the time that it'll take to finish an order. And then there is a pay rate that we apply to that time. And then that pay rate is what a shopper sees when they see the orders. So they can choose whether they feel like it's a good value for their time or not. And if they choose that order, for example, in this case, if they choose that order, they are guaranteed at least $16.90 if they go and finish that order, right? So they get to decide, whether they want to do that, whether they want to do something else, depending on, they will see a lot more orders, but this is just one example. So that's another machine learning model. The third one, so imagine an order again coming into the system. First you bundle it. You try to see if you can combine the demand into, aggregate the demand into a bigger pool. Then you price it, right? So that's the second model, which is you are trying to estimate now, given that demand, how long will it take to fulfill it. The third one then is you actually match it with the shoppers, and that's our matching system, which is the available orders. You're trying to match it with, for example, a simple example, very, very simplistic example is, if a shopper is in New York, you're not going to give them a San Francisco order, right? Like it doesn't make sense, right? So it's a very hyper-localized business. So there is a matching. That's just a very made-up example, but there are rules like that in matching. When is a shopper available? Are they available online? Are they a good quality shopper? There's all kinds of quality control that we have, for example, right? So things like that. That's number three. And then the fourth one is actually our surge system. We call it promo. But for the orders that are not getting cleared from the marketplace, suppose we match it, suppose we give it to a lot of shoppers, but the shoppers are still not claiming it for whatever reason, then we basically throw money at the problem at that point, right? Which is, just like rideshare, if there is a lot of demand, the demand is there, but the supply is not picking it up. You got to incentivize the supply in real time. And I think it's coming back. I think it's coming back. This one came back. Okay. Yeah. So you gotta incentivize the supply in real time. So we have a surge system which we call promo. And what you will see is on top of this 1690, for example, you will have additional pay, which is always, the last lever that we can pull in order to incentivize shoppers to pick up those orders and fulfill them. So let's get into how we launch machine learning models at the company. I'll set the stage for us. Again, I kind of talked about this in the previous slide. So this model that we use for estimating time and the money is called base pay. Just that's the internal name that we have. The reason why we call it base pay is because it's really sort of the first pay that you see when an order is offered out. It's sort of the machine learning models, they estimate that pay, and it's the first pay that you actually see go out. There might be other pay, there are actually other pay systems. Surge is one example, which is on top of base pay. There is another one, which is a target setting system, which is, a simple example is, shop X and get Y dollars. If you shop 10, get $10. So that's an incentive setting system. That's a different pay system. There are many pay products, but this is an example where we are going to talk about refreshing the base pay model. So we launched a new base pay model. We are about to just finish the launch, as I was saying before. So we're going to talk about that. So I'll give you guys a little more context into how things work at Shipt, and just an overview as to how the launch is structured, how we kind of go through the launch, and what does it take to actually launch a model. So just to set context, I think Aarti mentioned this in the introduction. This model actually has a P&L surface area of about $1 billion every year. So it's extremely sensitive for the company if it touches that much money. Number one. Number two, us being a gig company, right, with independent contractors, I'm sure all of us, any of us who have used Lyft or Uber, you probably are familiar with, there's always sort of this tension between, am I an independent contractor or am I a full-time employee, right? The 1099 versus W2 debate, anybody who knows. And things like that, they actually eventually come down to things like pay, things like choice. How much am I getting paid? Do I have choice or am I getting forced to work? Like, am I not getting enough choices, for example? That is sort of the philosophical line between, am I independent or am I an employee? This model is sort of at the linchpin of that, right? Because it is sort of touching, like I said, $1 billion. Because of this, if we make a mistake, if we have an error, let's say if we launch, something goes south. Let's say, there was this bug that happened one time. This is a very funny bug. So there is a system, there is a service obviously in the backend, which, every order that comes in, you query the service, and the service actually tells you, okay, I estimate that this is the dollar value that you should show for the order. Let's just say that, right? There was some glitch with talking to the service, and you were starting to see $0. And then that created a PR nightmare for us, right? Like, things like that happen. It's just simple things can cause like a butterfly effect. Because of that, there is actually a lot of brand impact if we make mistakes like that, which are really, they are not they're not deliberate mistakes, but they can actually cause like a lot of brand impact for us as well as regulatory impact. So again, as I said, the hot debate between are we independent contractors, are we full-time employees? A lot of that, for any of you who are familiar with Prop 22, for example, in California, there are laws like that, which, because this is such a hot topic, the people who work for these companies or choose to work for us, request some sort of guarantees for the work that they're doing and things like that. We have to respect minimum wage laws and things like that without going into too much detail. But it also has a regulatory impact. We will get audited. If we make mistakes, even if they are unintentional, we will actually get audited for mistakes. That happens a lot through the company. There are regularly, situations where I am working very, very closely with the legal team a lot of the times to be able to answer what happened in this scenario, what happened in that. And it comes down to, out of the millions of orders that we serve, billions of orders, it comes down to that order, that one time that the pay was, you didn't actually pay what you told that you were going to pay. Like, you paid a few cents lower. So things like that happen, and it comes from, Washington, D.C., and like from a lot of different states and AGs and all of that. So that happens a lot. So there is a lot of regulatory and brand sensitivity for the company. And because of that, and I want to emphasize this point, because of the surface area And because that some of the decisions that we make can actually have an irreversible impact on the brand, we actually choose deliberately to go through a heavy checks and balances process. So there's a lot of people involved in approving a model, in greenlighting a model. There's a lot of analysis that we have to do before we actually even talk to our executives. There's a big go no go meeting. So as I was saying before, for this model, this particular model that we're talking about, I remember pretty much everybody at the company, including leaders from customer service, because if something goes wrong, they get calls, right? Because if there are $0, they will get calls first. People from customer service, people from marketing, people from legal, people from finance, besides technology, obviously. Technology is the one that's building the model. Data science, engineering, product, design. Like a lot of us are it's a very, very cross-functional effort. And admittedly, it takes a long time to get to a point where we actually we will do a lot of analytics and we'll look at data. For example, how is it behaving on smaller orders of less number of items? How is it doing on large orders? How does it do for orders that have alcohol in it, for example, right? Because those are special orders for us. You need a special certification to deliver alcohol. What does it do for prescription meds? Like things like that. So you have to look at a lot of different cases before you launch a model. And we go through an extensive checks and balances review process. And also, as I said, P&L impact. So the operations team is involved, and they are the ones that are also driving the P&L strategy, the pricing strategy for the company. So all of us are sort of working together. It's a complex process, and with that many people, that many opinionated leaders in the room, it's also difficult to kind of manage that process. It takes time. Long story short. But that said, the way we launched was, in this case, we actually got the approval. It took us a few months. It took us a lot of deep thinking and analysis. We got the approval. We manually turned the model on in production. And the way we did it was we ramped it geographically. So we started with our lowest order volume is what we call it, where the number of orders coming into the marketplace, the lowest order volume metros as a test run. And then we started ramping it. And then we went to some of our biggest markets. So we slowly do it incrementally in phases. That's what we did. And after we launched, we basically monitor and see that if the model was if this is what the model was predicting, this is what the actuals are looking, right? So, and just one more thing, the reason why we actually chose to launch also is coming back to the previous slide for 1 second. So what happens here is that, so we do predict on a lot of variables, right? So for example, right here, you will notice that there is a time of day for which you predict, right? 9 to 10 p.m. in this example. The time that it takes to deliver an order at 9 to 10 p.m. or shop an order will be probably a lot lesser than, for example, 6 to 7 p.m. because it takes longer. And this is a time estimation model. Let's remember that, right? So it takes longer because it's peak time versus off-peak time. Where this is being deployed, right? What store it is being deployed, what area. A New York Target will probably have a lot more foot traffic and take a lot more time for estimating that time versus, for example, an Idaho Target. I'm making this up, right? So things like that. It takes a lot of those things into account. It also takes into account things that you don't see on this slide. So all of these things that you see are obviously inputs, but it also takes things into account. Things like what is the chance of substitutions or availability? So if a shopper goes to a store, think of us. When we go to a store, it's very intuitive for us, if we are shopping for ourselves and we don't find an item in the aisle, we just find something else right next to it. But a shopper actually has to go through a process where they try to talk to the customer in real time, sometimes. And they say, I'm not able to find this milk. Can I get the other one? Would you be okay with that? Because they can't just pick up something, what if the customer doesn't like it? Then they may not get tipped. The customer might have to return that order and things like that. So that is a process. So how long would it take? Would it take some time? So those things also, which you don't see on the slide, are also factored into the time estimations. Some of the things that you don't see. So what happens is that with time, as I was saying, right? With time, what happens is sometimes these things drift with time. So one simple example here is, let's take checkout. So one of the things that the model takes into account is the time it takes to check out something. And a lot of us know that a lot of checkout technology is getting automated, right? Cashierless checkout or just walk out, for example. Amazon Go is one example where you just walk out. If we continued paying on older time estimates and did not retrain the model, then we would be overpaying because the shoppers are taking lesser, they're finishing the jobs faster, but we are actually paying them more, which means it has a bigger P&L impact for us. So should we, when the models drift, the way we do it is we look at the actual times that the shoppers are taking, and we use them to train the models. And when we see that the accuracy drifts, we think that the models are now under-predicting and the actuals are higher, in this example, then we will retrain them and we will relaunch them. And that's what we did in this case. That was one of the reasons why we decided to refresh the model. All right, so story number 2. This is, I don't know if any of you guys have seen this, but I've seen this not once, but a few times in my career. As we were doing this, the data science team had worked super hard. The engineering team had worked super hard on trying a few new technologies, etc., in building the model. And it was all hunky-dory, except the problem was that the accuracy of the new models that they had built, the tech was better, admittedly better, but the accuracy of the new model was actually not much better than what we had live in production. And so the tech team was trying to make, and we consider ourselves as part of the tech team as well because we are product, but the tech team was making a pitch that there's sunk costs. We've spent a lot of months on this. If we don't launch this, the team morale will get impacted, et cetera, and so on. I've seen this happen multiple times in the company, at different companies. But unfortunately, we had to make a hard call with the tech team and say, that's not the reason why we launch. We launch if it actually improves things in the marketplace. If it improves the accuracy, prediction accuracy, if it improves the time estimates, and the data shows us clearly that's the case, then we will launch. We will not just launch just because we have some new shiny toy or new tech. We are not going to launch it. So that was one area where sort of we had to kind of manage with the team, manage their expectations essentially. And we went back, we kind of like looked at what more can we do? Can we train it in different scenarios? For example, I called out some of them, retrain that and kind of try to improve the global accuracy and then launch the model. So that happened a lot. That happened once, and we had to actually move past that. And then finally, this was another thing that came up. And I think this philosophically comes up, for us as people who work in AI, this comes up a lot, especially for consumers who are not as close to the problem spaces as we are. A lot of people will think of AI as, trying to replace humans, right? Like ChatGPT is a classic example, generative AI. People are saying that it will probably replace journalists, right? Because it can write articles, it can do your homework. I think somebody used ChatGPT to clear MBA exams and things like that, right? So it's a real thing. But in the company, we have a strong philosophy, and I think I talked about some of this before. We do use checks and balances, and it's by design. We don't wish to automate everything. So we think of machine learning as assistive to humans, not alternative, right? That's the philosophy we take. And two actions or outcomes because of that philosophy is, number one, we do not wish to automate model launches. So what that means quickly is, there is a process called champion promotion, which is, you can train multiple models, on your data. And if the new model actually performs better than what's out there, you can automatically rotate that model. This happens a lot in online models, especially like search, et cetera, because they have very high frequency training, and and they have to be refreshed very fast. So that happens. But we have taken this deliberate approach that because of the P&L surface area, we're not going to do that. We are actually going to do it using humans, right? So that's sort of, our philosophy is that we will actually use a manual process to keep doing this because errors are extremely costly and mostly non-reversible. And then the second thing is, we will build tools in order to support that process, to help our operations teams in order to run the marketplace better. So we build a lot of analytics and dashboards so they can look at the performance of the model after it's deployed. We focus a lot of our resources and time and energy in supporting that process, essentially. All right, so I'll wrap it up. The main things that I have learned through this process and even otherwise is machine learning, especially when you have models that impact your P&L at the company, it's hard. So the best thing that you can do for something like this to drive consensus, when you have so many people, have an opinion and it impacts so many people, is try and find out a metric that you can use, right? Like I used the word accuracy. a lot. So that is a metric that we index on. That's our North Star. And if the accuracy improves, then we will greenlight a launch versus otherwise. Try and find a metric. It's not easy, but that's the best way to start and get alignment across the company. Do not launch if there's sunk cost. That's not a good reason to launch anything. And then finally, for predictive use cases versus generative use cases, generative AI, for predictive ML, definitely build auditability and have some human oversight. This is the principle I mentioned. So have some human oversight in the cases where it will impact your P&L. So building traceability, building understandability in the models is important because you get questions, you get regulatory audits, and you have to be able to explain how the model behaved in a certain scenario. And that's it for me.